welcome to 4C. It's going to be very, very similar to 4B, but now we're going to do quadratic-like problems. They don't start out quadratics, but as we're working through the problem, we actually make them quadratics. So a couple little problems here, quick, that have previous knowledge that I need to refresh before we move on. So if I have x squared to the fourth power, what would that equal if I simplify it? It'll be x to the eighth. We multiply exponents when raised to each other, power to power. So multiply these, you get x to the 21st. Keep that in mind for the next problems. So these are quadratic-like problems. They're trinomials. There are three terms here. They kind of look the same, but they're not a quadratic. They're the sixth power quadratics. They're squared. So we have to kind of think, how can we get this to be a square? So what you're going to do is, I'm going to break this up into, I'm going to make it to something to the squared power. Thinking back to what I just did on the last page, what do I put inside here? X to the what power to the second power would make that, would it be equal? Well, if you're saying to the third, because power to power, you multiply them. And now we have minus 10. We just keep it x to the third. I'm going to put it in parentheses just for now. What I'm going to do now, instead of x to the third, because this is kind of ugly, this part right here, this is all ugly. It's just power to power. There's too much going on. So what I'm going to do is just temporarily pick a letter, any letter you want. So the letter I choose is not the letter you have to have. So if you want A, make A equal, what's in parentheses, x to the third. If I do that and I replace x to the third with an A, you just get A squared. If I replace this x to the third here with an A, you get just negative 10A and plus 21. Now you're telling yourself, hopefully, oh wow, I see that A squared minus 10A plus 21, the coefficient is 1 now, and this makes it a really easy problem to factor. How are you going to factor it? The coefficient of 1 from last video is what two numbers multiplied with negative 2 or positive 21 that'll add up to negative 10. And that is negative 7 and negative 3. First term is A squared, that's just A times A. The problem here is this expression did not start out with A's in it, so it cannot end with A's. So now we need to go a little bit further. We need to replace back, we need to replace the A's. What do we need to replace them with? We need to replace them with x to the thirds. So where there's an A, replace it with x to the third. You don't have to do this replacement at the very beginning. It just makes, so you really don't have to do it at the beginning, this whole thing. If you can do this without it, great. I think substituting makes it much easier. So we have x to the third minus 7, x to the third minus 3. We look, x to the third minus 7, that's not a perfect square binomial. X to the third minus 3, not a perfect square binomial, so we're good. Let's move on. So we have, well, how can I make, this is x to the fourth, how can I make that x squared? What here can I put that will make it an x? So I want to make it squared, so it has to be x. 2 times 2 is 4, so the thing we're going to replace, you can choose any letter you want. We're just going to replace the x squared with A. So what's in parentheses, I replace that with the A here. And now I see that it's a perfect square binomial. Square root of the first term is 4A. Square root of the second term is 5. So I have a perfect square binomial. You have two binomials that are the same, except for one thing. One's a plus, one's a minus. Does not matter which one you have. Now the problem did not start out with A's, it started out with X's. So we need to look back at what we substituted. We substituted A for x squared, so let's substitute back. So instead of A, I'm going to put an x squared. And look at the problems as I'm boxing it in. 4x squared plus 5, that is not a perfect square binomial. 4x squared minus 5 is not a perfect square binomial, so I cannot factor it any further, so we're done. Next, we have 12x to the 8th minus 31x to the 4th plus 7. Looking at x to the 8th, I got to make that x squared. So what can I put here that will make this a squared term? Well, x to the what power? Power to power multiply, so it's got to be 4. So I'm going to take a variable, let's say u this time instead of a. You can always use a. I'm going to say u is equal to x to the 4th. So we have minus 31. We already have an x to the 4th here, so that's going to get replaced. Substituted. So instead of x to the 4th, we put u. Minus 31. Instead of x to the 4th, we're going to temporarily substitute u in there. Now we have a perfect square, or not perfect square, a trinomial. Now, not a leading coefficient of 1 though, so now we got to go to do the a times c, so 12 times 7, 84. Put two terms multiplied 84, that will also add up to negative 31. And with doing some work on the side, I saw that negative 3 and negative 28. Again, if you didn't come up with this in your head, fine. I'll show you a way in class to come up with problems if you're not really good with your factors. My guess is most of you are. So we have negative 3 and negative 28. You're going to do Punnett square. I showed you one way to do a Punnett square last time. Here's another. Just make a box. Top right is the first term. Bottom right, last term. The two numbers you picked go in the middle. And then we have u. So greatest common factor in the bottom row, 7. Greatest common factor top row, 3u. Greatest common factor first column is 4u. Greatest common factor last is a 1. And I see that the negatives are not matching up. So if there's a negative and if both your numbers over here were negative, you're going to have a negative and a negative for the numbers. So we have 4u minus 1 and 3u minus 7. Look back at what we substituted. Up a little bit. We substituted here for u. So replacing u, I got to replace it back with x to the 4th. So let's do that. 4x to the 4th minus 1 and 3x to the 4th minus 7. Alright, usually where we'd be done here, well, each problem you've noticed I've looked at each individual binomial and seen if there's anything special about it that I can break it down, I can factor it further. It just so happens this 4x to the 4th minus 1, I can factor that further. I can square root the first term, which gives me 2x squared, and I can square root the second term, which gives me 1. And there's a subtraction in the middle. If there's a plus in the middle, you cannot factor it. So with this, I can actually factor it further. So the first terms, you get 2x squared, 1, 2x squared, 1, and 1's a plus, 1's a minus. This last term over here, because it's a 7 and a 3, I cannot factor that further. They're not perfect squares. And now this is my final answer. There's none of the terms, 2x squared plus 1, 2x squared minus 1, those are not, cannot factor them down any further. 3x to the 4th minus 7 cannot factor that any further. Next. Alright, back to it. So we have x to the 6th, I gotta make that square. So 25, what can I do squared? And you should be saying x to the 3rd. So I'm gonna go back to a. I like a's. A's are good. I'm gonna replace a with x to the 3rd. So I have 25a minus 4. Perfect square binomial. Awesome, we just did a problem like that. we have 5a and 2. So this is going to be 5a plus 2, 5a minus 2. And let's replace it back with x squared. And see if we can factor it further. 5x squared third cubed. 5x cubed plus 3 and 2. Get my 2's and 3's mixed up. 5x to the third minus 2. Looking at it, neither one of these are perfect square binomials. I cannot factor further. No greatest common factor. Oh, I just dropped that word. Greatest common factor between them. So we're good there. Here, speaking of greatest common factor, if there's a greatest common factor between all of your terms right away, make sure to take that out right away. So we have the greatest common factor between these two terms is y. So the GCF, take that out. So GCF, always think GCF right away. None of the other problems we've had has had it. So we're going to factor out a y out of the terms first. Now we have y to the fourth. It's quadratic like. It's a fourth instead of square. So what can I do? Y to the what power will give me a square? You should be saying 2, hopefully. I'm writing this all backwards, but okay. We have this. Replace the y squared with any letter you want. So let's go with c equals y squared. So we have the y on the outside from the greatest common factor, and we have c squared minus 81. Replace that y with c. So we have c squared minus 81, perfect square binomial, square root of the first term, c, square root of the last term is 9. So we have y on the outside, c plus 9, c minus 9. Let's replace it back with the y squared. So y squared plus 9, y squared minus 9. So let's look, see if we can factor anything further. My first factor, y, no. Y squared plus 9, I have perfect squares, but it's a plus in the middle. For the plus, you cannot factor it. And the subtraction here, we can. So this next term, we can square root both of them. That's going to give us y minus 3, y plus 3. Don't ask me why I just wrote 2 different y's. You should know me by now. So now we have everything's all factored, nothing can be factored further, broken down. So we undid the problem, unsimplified it, really got the factors. Come to class with any questions. I know it was long, I apologize. Bye-bye.